Qualitative analysis and solubility. We can old school determine the identity of a material by matching it to materials that we do know, matching it to the chemical behavior of materials that we do know. So this week in our lab, we're going to take solutions of magnesium nitrate, nickel nitrate, chromium nitrate, zinc nitrate, and silver nitrate, and react them with solutions of hydrochloric acid, dilute sodium hydroxide, more concentrated sodium hydroxide, and that same concentration, 6 moles per liter of ammonium hydroxide. As always, I am wearing my lab goggles, even though you can't see it, and my lab coat, so I can protect my clothing and still be safety conscious. Now, some of the chemistry that's involved in this lab is beyond the scope of the course, in that, for example, transition metal ions, the metals that are in the middle of the periodic table that we fundamentally ignore in this class because they have unusual behavior that you may not study until graduate school. Transition metals behave differently due to something called complex ion formation in the presence of small amounts of hydroxide versus large amounts of hydroxide. And similarly, in the presence of ammonia, the transition metals can behave differently, even though it's ammonium hydroxide, differently than they do in the presence of sodium hydroxide. But main group elements don't show that unusual behavior. They will behave the same, whether it's dilute or concentrated sodium hydroxide or ammonium hydroxide. And so having main group, transition element, different kind of behaving transition element and different kind of behaving transition element, we can see those different behaviors. And what we know is that our unknown is going to be one of these. If we had absolutely no idea what our unknown was, the experiment would be a little bit more challenging, but still doable via old school methods. New school methods are instrumental and more technologically based. Just run the thing through a GC mass spec or an atomic absorption spectrometer, and you can determine the identity of unknowns that way. But this is old school qualitative matching. We're not determining how much is present. We are only determining what is present. And we know that they're present as the nitrates, okay? You can't just have cations without anions. Our anions in all of our cases are nitrates. This lab also focuses on good data recording because on your data sheet, you need to record at least 2 words in every box. Can you see through the resulting solution? Is it clear / transparent? Or is it opaque or cloudy? And also you need to note what color it is. Clear is not a color. Clear means you can see through it. You could be clear in red or clear in blue or clear in purple. Variety of different colors that you could see through that are transparent. We are going to record clear and colorless if you can see through it and there isn't no color. We'll record clear in green or clear in blue for some of these, that you can still see through them. Or cloudy in blue. We can't see through it, but it's still looking blue. All right. We are also going to record what they look like before we add anything to them. Okay? Before we add anything to them. Just so that we have a good record of the changes that occur upon mixing these things. So I've put my well plate, which is relatively clean, although you can see some schmutz left in this one, on top of 2 different sheets because I'm going to run a bunch of unknowns, 5 different unknowns. And we'll see what we get. Okay, so first I'm going to start off with doing my hydrochloric acid, my sodium hydroxide, my more concentrated sodium hydroxide, and my ammonium hydroxide in each of these wells, and I'll repeat it going down each of these. Now it says 10 drops each, but we don't need to be that careful in our measurement because this is qualitative, not quantitative. So I'm going to grab some hydrochloric acid. All right, hydrochloric acid, 0.1 moles per liter. And assuming the dropper works on it, I'll put roughly 10 drops into each of the wells. Dropper doesn't work, so I will put it aside and I will use my own dropper. Okay, so 10 drops, if I was counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I might be here all day. So I'll just do a little squirt in there, a little squirt in there, a little squirt in there, and so on, all the way down. And I'm going to do that also in this one over here. 10 drops or so, all the way down. Okay, and I'm done with my HCl. Now I'm going to get my 0.1 molar sodium hydroxide. Sodium hydroxide, 0.1 molar. Let's see if the dropper works in this one. Oh, it does. Okay, so same thing. 10 drops or so, all the way down. Note that the hydrochloric acid, before I add anything to it, and the sodium hydroxide, before I add anything to it, are clear and colorless. I can see through it, and there is no color. So on my data sheet, that's what I'm going to record. Since this is a data sheet that is just for myself, I can write C/C knowing that that means clear and colorless. C/C, right? Clear and colorless for each of those. You can maybe do your own notation or write the words out, clear and colorless, when nothing is added to them. On to the 6 molar sodium hydroxide. Okay, 6 molar sodium hydroxide. So I do roughly 10 drops all the way down. I could be wearing gloves for this, but I'm just choosing not to and to be careful. And if I do get any of these on my skin, I will rinse them off. And last but not least, well, that 6 molar sodium hydroxide was also clear and colorless, so I'm going to write that down. Notice I'm writing in pencil, which I really should not be doing. No pencil in the lab. Pen only in the lab. Ammonium hydroxide. 6 molar ammonium hydroxide. Stopper doesn't work, so I'll get a different one. Ammonium hydroxides is commonly known as Windex, if it was colored blue. Also known as smelling salts in a first aid kit. And so this is rather potent smelling, but I am just not getting it near my face. Notice also clear and colorless, just like the others. So in pen, I record clear and colorless for the ammonium hydroxide. I'm going to come back and do the unknowns at the end, so I'll jump to the magnesium nitrate. Magnesium nitrate, also 0.1 molar, although the concentration is not written on the data sheet. So 10 drops or so across the magnesium row. And let's see what happens. Notice, before anything's added to it, clear and colorless. So 10 drops or so. Now, you can't really tell what's going on because we haven't stirred these, and we need to stir a solution to make sure that it's a solution. So I'm just going to use a pipette, and I'm going to squeeze it, and that'll stir it. Okay, so I'm just squeezing it in and out, making sure that it all goes out before I moved on to the next one. I really should use a clean pipette or a stirring rod or something for each one, but this is a nice and fast way, and I can get it all out just by squeezing it out. Right? So in and out, squeeze, 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 stirring this one, get it all out. The next one. Try to get it all out, and to the next one. Now, the magnesium was clear and colorless when I started, but if you look, in the NaOH one, the dilute one, if I move it over the line, you can't really see the line there anymore because this is cloudy and white. The 6 molar sodium hydroxide also, it's a little cloudy and white. Cloudy and white with the ammonium hydroxide. I can't see that line anymore. So I don't know why this one is a little bit lighter, but we could record that if we wanted to. This seems to be a little bit lighter, even though it's a more concentrated 6 molar sodium hydroxide. Okay, so cloudy and white, cloudy and white, cloudy and white. That's what I'm going to record in pen. This, the hydrochloric acid, was still clear and colorless, right? Nothing going on in the first one. Clear and colorless. This was cloudy and white. Cloudy and white, cloudy and white. Okay, on to the nickel. Nickel nitrate, 0.1 molar. Same thing, going across. This one, before we add anything to it, is a little bit greenish, but still see-through. Green but see-through. The nickel, nothing with HCl, still greenish and see-through. The sodium hydroxide changed to a little darker color. We'll have to see if we can see through it after we stir it. Ooh, quite the color change. Well, that one should be easy to match. Let's stir them just to be safe. Looking at them, the HCl still see-through, transparent, but still that same green that it started with. With a little bit of NaOH, 0.1 molar NaOH, cloudy and green. 6 molar NaOH looks like a little less cloudy and green. And this one, with the 6 molar NaOH, just moving it over the line so you can see it, check out the line in there from the grid, is now blue but see-through. So that's what we record, right? Without anything in there, this was clear but green, I'm going to call it. You call it whatever color you want to call it. This was no change. Still clear and green. This one was cloudy and green. This one was less cloudy and green. And this one was clear or transparent, your choice of verbiage, but blue. Moving on. Chromium. Find one. Here we go. Chromium 3, also known as chromic nitrate. The dropper doesn't work. Use a clean other one. This is see-through but purple. Transparent purple to start with. Transparent purple. Write that down. Into the chromium row with the hydrochloric acid. Key point here is that we've definitely got completely different physical behavior due to the chemical behavior, right? There's a chemical reaction going on here between these things, and we have different colors. Chromium looks very different than nickel, looks very different than magnesium. That's great for us. We can figure out what we've got. Stirring them again. These are some old solutions, haven't been used in a while, so there's some chunks of stuff in there that we're just going to ignore. That's a gross looking one. It's so foamy it's hard to tell what's going on there. Try and pop the bubbles. Wow, it's really foamy. We don't want to count the foam, we want to see what color this stuff is. They're popping. We'll give it a minute. All right, so the chromium when we started was clear but purple. Recording in pen, not in pencil. And it doesn't look like it really changed with HCl. Right? I can still see the line through there, and it's still purple. So no change. What I'm writing on my data sheet. This one, it's a little hard to see because it's so foamy. Lift it up towards the camera a little bit. Try and move some of that foam out of the way. This is lab science for you. Sometimes hard to tell what's going on. I'm gonna lift it up, and it won't be on camera. I'm gonna carefully, not spill it on my face, look at it from the side. This is cloudy but green. Okay, chromium plus a little bit of sodium hydroxide is cloudy and green. It is a darker green than the nickel, but it is definitely a green. So it went from purple, it turned color to green. The nickel started green and went cloudy to green. So I'm going to call this cloudy dark green. This one, if you look carefully, you can still see the line from the grid underneath it. So this is a clear, dark, even green. And then this last one is a cloudy green that's the same as this. So this sodium hydroxide and this ammonium hydroxide that's more concentrated look very similar, ignoring the foam. So I'm going to just call that a cloudy dark green, not cloudy darker green. Okay, so on my data sheet, I've recorded what I think each of these look like. You can certainly record what you think they look like. On to the zinc. Clear and colorless to start with. 10 drops or so in each one. Clear and colorless to start with. I'm recording that on my data sheet. Gonna stir each of these. Just moving it over so I can look at the line of the grid through it to see if I can see through it or if it's cloudy. The hydrochloric acid looks unchanged. It's still clear and colorless. So that's what I'm recording on my data sheet. The sodium hydroxide 0.1 molar is definitely cloudy and white. The 6 molar sodium hydroxide, back to clear and colorless. And ditto for the ammonium hydroxide. It's back to clear and colorless. So that's different than the magnesium. They look pretty similar, but there's a definite difference. These were all cloudy and white for the magnesium. This one was cloudy and white for the zinc, but the other two went back to clear and colorless, demonstrating the interesting behavior that's different between a main group element, magnesium, and the transition element, zinc. Last one, silver. Sort of an expensive experiment to do, but we can do it. Silver nitrate in the bottle. I don't know if you'll be able to tell because the bottle itself has gotten a little discolored. I'll hold it really close. You have to ignore the gray in this one, sorry, and just look at the liquid in the tube, in the dropper, which is clear and colorless. So it's clear and colorless. The tube itself has gotten discolored, but it's clear and colorless. And when I add 10 drops or so into the HCl, into the NaOH, into the more concentrated NaOH, and into the ammonium hydroxide. And we stir each one. Cloudy and white. Cloudy and brown. Cloudy and brown. Clear and colorless. Was clear and colorless to start with. Nothing in it. Cloudy white. Cloudy brown, I'm going to call it. Also cloudy and brown. Clear and colorless again. Let's move on to the unknowns and see if we can figure out you'll be assigned one of these 5 unknowns. Unknown number 3. What it is based on its behavior. Let's see if we can figure it out. Starting off clear and colorless, see it in the tube. I'll add 10 drops or so, 10 drops or so, 10 drops or so, 10 drops or so. And stir. So if you are assigned unknown number 3, this is the one that you'll record on your data sheet. I leave it to you to decide what the observations are. Okay. Unknown number 3. Moving it over so you can see whether you can see the line underneath it. It was clear and colorless to start with, so that's what we would record on our data sheet. Okay. Unknown number 3 is clear and colorless. And then we decide what each of these are. What is it when it's with HCl? What is it when it's with the 0.1 molar NaOH? 6 molar NaOH? 6 molar NH4OH, ammonium hydroxide. Okay. On to unknown number 15. Here it is in the tube. Maybe you can tell what it is already, even without adding it to anything. Looks like it's see-through, but purple. Did we have a see-through but purple one more than one? I don't think so. Wow, this one's tough to open. All right, I got it. Unknown number 15. Give me just a stir. Try not to make it too foamy. Okay. Unknown number 15. Zoom in for you. You can see the line through there. That's clear or transparent and purple. That's a cloudy one. This one, it's pretty dark, but you can totally see the line in the middle if you look really carefully, if it's not too glary. This one's definitely, you cannot see the line. All right, so that's your observations that you're going to record for unknown number 15. Let's go to number 7. There's number 7. Can you tell what it is before we even start? Write down your observation for what it looks like before we even add anything. And then let's add it to each. All right, just having trouble getting it out of the test tube. My dropper is not cooperating. All right, making a little bit of a mess off camera that you can't see. Here we go, number 7. And I'll move it so you can see whether you can see through the line or whether it's transparent or not. And match it to one of your previous observations. 19. Oh, sorry, show it to you before I add it to anything. 19. Which one did we have to ignore the discoloration of the tube for? Qualitative analysis using your spectrometers known as your eyeballs. That you can see in the pipette, it's definitely clear, colorless liquid, number 19. Number 19, clear and colorless. And we'll add a little bit to each one. Give them a mix. Okay, move it over so you can see whether you can see through them. Definitely can't see through it. Can't see through it. Can't see through it. Can see through it. Number 19. And I wrote down number 16. Is that the one I want to do? Let me see. No, we're going to do number 10 instead. Number 10 will be our last one. Number 10. Another clear and colorless liquid. Here we go. 10 drops or so. There we go. Stir them up. Clear, colorless. Looks a little cloudy, whatever color you want to call it. Clear, colorless, clear, colorless. So let me unzoom. And we can compare carefully. Unknown number 3 to magnesium, to nickel, to chromium, to zinc, to silver. Number 15, number 7, number 19, and number 10. Do a close-up of each one. Magnesium, nickel, chromium, zinc, silver. Unknown number 3. Unknown number 15. Move it over so it's on the line so you can see a little better. Unknown number 7. Unknown number 19. Unknown number 10. Qualitative analysis of ions. Were we able to accomplish our goal of identifying an unknown cation? How do we do it? See you next time.